Good morning. Today we will start the course from M.ScII part 2nd. The name of course is CHO 351 and from this subtopic is 13C NMR spectroscopy. Now NMR is nothing but the nuclear magnetic resonance spectroscopy. Now before starting this 13C NMR, we will see something about the PMR. So one question is here, what information we obtain from PMR? And we will see one by one here. So we got the information from PMR is that types of proton. Types of proton is depending upon the environment of that particular proton. Suppose we take one example here. Ethane and another is dimethyl ether. In this case, this CH3 and this CH3 are the chemically equivalent and having the same chemical environment. At this simultaneously, in diethyl ether, the CH3 and CH3 both having the same chemical environment, and hence here we consider the types of proton is only one. But when we consider different example here, ethyl chloride, we replace one hydrogen by chlorine, and here this CH3 having different chemical environment and this CH2 having different chemical environment, and hence this compound having the two types of proton. Means in case of this PMR, the types of proton is depending upon the different chemical environment. And one important thing is here, when there are different types of proton, it gives different signals. Means this compound gives two signals. Now when we consider the second point from the PMR, that is multiplicity. Multiplicity is generated from the spin coupling. Multiplicity is generated from the spin coupling, and here in case of PMR, formula is that n+1. Suppose we take example here. Again diethyl chloroethane, here A, this is B, and we apply the formula n+1. N is the neighboring protons. Here neighboring protons are 2 plus 1, and hence it gives triplet, and signal is like this way. Now consider B, n+1, here 3 plus 1, means it gives 4 lines. 4 lines is nothing but the quartet, and signal looks like this in the spectrum. Means from the PMR, second thing we obtain the multiplicity, that is spin coupling. And next one, proton ratio. Proton ratio is nothing but the area under the peak. Means here this signal is appear for how much proton appear for how much proton, means it gives like this way, and this signal is appear for 3 hydrogen, and when we consider this one, this signal is appear for 2 protons, means third point is regarding or related to proton ratio. And next point, that is coupling constant. And coupling constant is noted by J. Suppose here again we take this example, chloroethane. This is A and this is B, and suppose this is the spectra. We draw the rough spectra here. This is TMS. This is the signal for CS3, and this is the signal for CH2. Coupling constant is nothing but it is J value, and for CH2 this is JBA, and for CS3 it is JAB. And one thing to remember here, JAB equals to JBA. In this case, this is 7 Hertz. Now, which information we obtain from the coupling constant? That is coupling partners. You know the coupling partners. And next point is that this is very important, that is chemical shift. Means suppose this is CS3 and it is 1.1, and this is near about 1.7 due to the shielding. Means chemical shift value is depending upon shielding and de-shielding. Means we obtain these important things from the PMR, that is types of proton, multiplicity, proton ratio, coupling constant, and chemical shift. Now, when we consider the CMR, there are somewhat difference in between PMR and CMR. So, we will discuss about the difference in between CMR and PMR. Differentiate between CMR and PMR. Here we consider CMR and PMR. Now before starting this, actually 12 carbon atom and 13 carbon atom are the isotopes of carbon, but this 12 carbon atom is NMR inactive because I equals to 0, that is spin quantum number is 0. But in case of 13C, this is NMR active and I equals to 1/2. Okay, so difference here, different points we will see one by one. It is natural abundance. Natural abundance of PMR means proton is 99.98%, but in case of CMR 13C is only 1.11%, only 1.11%. Then sensitivity, here 1, but in case of CMR it is less than PMR 5700 times less. It is 5700 times less than proton. And then absorption spectroscopy, absorption frequency in megahertz. Suppose we consider here 100, then it is 4 times less than PMR, means here 1/4. Now due to the difference in between 13C and H1, that is natural abundance as well as sensitivity as well as absorption, there are somewhat difficulty to scan this CMR spectra, and that's why when we consider the next point, scanning, in case of PMR, suppose we take any particular example. Suppose we take here propane. All these 8 hydrogens are H1 and all are NMR active. All are NMR active. Why? Because natural abundance is 99.98%, near about 100. Means in organic compound, we take any particular organic compound, all protons are NMR active. So there are, when we consider the scanning, this PMR is having the single, we obtain the spectra by single scanning, means single scanned spectra, but there in CMR there are somewhat difficulty, that is not any particular carbon is 13C, We take this example again. Means suppose we consider there are 3 carbon atoms and we noted here 3, 1, 2, 3. Now probability of this first carbon atom is only 1.11%. Means this carbon atom is more times 12C and only one time it is 13C. So we scan this compound multiple times and hence we observed or we obtained the spectra by multiple scanned spectrum. This is the major difference in between CMR and PMR. And suppose you consider the sample required for PMR, we required 1 to 5 milligram sample for the scanning of the compound and to obtain the spectra, because it is single scan spectrum. But in case of CMR, we required more than 100 milligram sample for the spectrum, because not only one compound or one molecule gives the spectra, because the natural abundance is only 1.11%, as well as the sensitivity is near about 6000 less than PMR. So this is the major difference in between CMR and PMR. Now when we move towards the spin-spin coupling, when we move towards the spin-spin coupling, spin coupling in CMR. Now in PMR, we already discussed about this. Another formula n+1. Actually, this formula is coming from spin states 2 Ni+1. Here I is the spin quantum number 2 into n into half plus 1. 2 to get cancelled and n+1. Same formula is applied for 13C NMR, because 13C also having the spin quantum number half. So formula is the same, n+1. Okay, now we will see one by one here. N is the neighboring proton in case of PMR, but in case of CMR, the proton attached directly to carbon atom. I will see one by one. Now here, suppose no proton is attached to carbon atom, then n+1 equals to 0+1, that is 1, it gives singlet. But when one proton is attached here, then n+1 1 plus 1, and it gives two lines. Two lines are looks like this. Then suppose there are two protons, and as per the formula n plus 1, 2 plus 1 equals to 3, it gives triplet. And suppose 3 protons are attached, then as per formula n plus 1, 3 plus 1, it gives 4 lines, and 4 lines are look like this. 4 lines are looks like this. And finally we will move towards the chemical shift. Here, suppose you consider the sp3 hybridized carbon atom is nothing but the saturated carbon atom. Then the value is 8 to 60 in ppm. And suppose sp, that is alkyne, then it is 65 to 90 ppm. And in case of sp2, we take example here, alkene and aromatic, it is 92 near about 150 ppm. And for carbonyl compounds, it is 155 to 220 ppm. Means here chemical shift values is depending upon the hybridization. It is depending upon hybridization. And here the major difference in between PMR and CMR is that in case of CMR, the range is from 0 to 200 ppm, but in case of PMR, this chemical shift value is from 0 to 20. Now here, when we consider the different protons attached to this carbon atom, such type of carbon atom is called as quaternary carbon atom. And quaternary carbon atom is observed in sp3 also. It is also observed in sp2 as well as in sp. Suppose in case of sp3, example ethane. In case of sp2, right? No, suppose we consider the quaternary carbon, then here in case of sp2, here attach different groups other than carbon. And in case of sp, here suppose Cl, C triple bond C, and suppose here Cl. And also there are some another examples, majorly carbonyl compound, carbon, nitrogen, etc. So this is the some examples related to spin-spin coupling. Now we will stop here and today we will summarize the CMR and some difference in between PMR and CMR. Thank you.